Okay, dear participants, we will now commence our program. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The honorable guest speaker for our today's session, Professor Carlos Mendez from Nagoya University, the honorable head of Economics Department, FEBUB, Bapak Dr. Polveri Prasetya, and all the audience for today's sessions. My name is Girindra, and it is my pleasure to welcome you and serve as your master of ceremony today in the 3-in-1 lecture series, Regional Disparities in Developing Countries. In the first 3-in-1 series of 2022, the Department of Economics, FEBUB, collaborated with Nagoya University, Japan. Previously, we have Professor Somea Masakatsu, and today we have Professor Carlos Mendez. And finally, on Friday, we will have Professor Christian Samen Ochia. If you missed the previous guest lecture, you can rewatch it on the Department of Economics official YouTube channel. Now, before we start with our agenda, let's first listen to the opening speech from Bapak Dr. Polveri Prasetya. The screen is yours, Pak.
Thank you, Girin. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Good morning, everyone. Very warm greeting to our distinguished guest lecturer, Professor Carlos Mendez from Nagoya University. Ohayo gozaimasu. And our lecturer from Department of Economics, Faculty of Economics, Brawijaya University, and all participants and also our student. As a head of Economics Department, I am more than grateful to stand here and welcome you all in our 3-in-1 program, as mentioned by Girin previously. And as part of 3-in-1 programs, our guest lecture today by Professor Mendez will not only guide us all about the also educated or regarding a variety of this pertaining to especially regional disparities in developing countries like in Indonesia. Maybe Professor Mendez can also share his knowledge about the disparities in Indonesia, especially. Yeah, and we all are certainly grateful for this prospect, and all the vital aspect regarding these topics will be conveyed to you all. And I wish this guest lecture enlightening us and give some insight to all of you and provide us with the approach to deal with the problems of tomorrow. And the last, thank you very much to everyone to make this program possible with their opinions and view. Thank you, Professor Mendez, to come to our seminar series. Assalamualaikum warahmatullahi wabarakatuh. Good morning.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Bapak Ferry. Now, without further ado, let's start with our main event, the guest lecture from Professor Carlos Mendez, which will be moderated by one of the lecturers of the Department of Economics, Ibu Yeni Kornitasari, MA. The screen is yours.
Thank you.
Okay, thank you, Mas Kirin, as our master ceremony today. Okay, before we begin our guest lecture in 3-in-1 program by Economics Department, dear all participants, are you ready to give attention in our guest lecture today? Okay, please give your reaction at Zoom if are you ready. And please, if you don't have any trouble with connection, please open your cam. Thank you. Okay, our seminar is about regional disparities in developing country. Will be begin. Please have a nice attention, and thank you very much for joining in this seminar series. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. The Honorable Prof. Carlos Mendez as our guest lecturer from Nagoya University, Japan, and the respectable Head of Economic Department, Dr. Relpo Ferry Prasetya. And thank you very much for your attention for all participants today. And I'm Yeni Konitasari as moderator today. I'm very pleased to see you in this agenda. Today's seminar is about regional disparities in developing countries, and very interesting topic, and we hope we can take insight for our academic activities. Our speaker today is Prof. Carlos Mendez. He is from Nagoya University. Oh, how are you, Prof. Carlos?
Yes, yes.
Okay. This is the time for the first time he is come to in our department. Okay, before presentation begin, I will read the CV our speaker, Prof. Carlos Mendez. He is Associate Professor of Development Economics in Nagoya University. After studying commercial engineering in Bolivia and Chile, he worked as consultant for major international, the World Bank, DNID, and CISA, and he has a MA degree in 2012 and PhD International Development in 2015 from Nagoya University, Japan. Okay. His research interests focus on integration of macroeconomic, spatial data science, and econometrics to understand and inform the process of sustainable development across national regions and countries. And the current research deals from Prof. Carlos Mendez with geospatial inequality and development, regional economic growth and convergence, regional labor markets outcomes and macroeconomic shock, and structural change and productivity dynamics. Okay, before the presentation begin, let me inform to you have the presentation will be going on this agenda will be running out more or less 2.5 hours. So I will divide this agenda on 3 sessions. First, Prof. Carlos Mendez will be invited to present the material more or less 2 hours. After that, there will question and answer session. For the participant, if you have any question, you can chat on chat feature and Zoom, or you can raise your hand when this session. And the last followed by conclusion. Okay, now allow me welcome to the speaker today, Prof. Carlos Mendez, to deliver your material. The screen and time is yours.
Thank you. Thank you very much. So let me share my screen. So, hopefully you can see my screen. And first of all, thank you for the invitation. It's a pleasure to be here. And because today it's going to be a lecture about regional inequality and development. And usually what I do in my lectures, I like to have feedback from students so they can also participate. So when we use Zoom, I'm going to ask you to give me some reactions so we can be on the same page. Is that okay? So if that's okay with you, give me a Zoom reaction just to start warming up. Okay, are you ready? Okay, great. So here we go. The topic of today is regional development and inequality with an emphasis in developing countries. My name is Carlos Mendez, and I'm an associate professor at Nagoya University. So the outline for today's presentation is divided into 3 parts. First, we are going to try to have a motivation for why studying regional development is interesting and also important. Next, we are going to study regional development from a very unique perspective. We are going to study development from outer space. Third, when we study development from outer space, we essentially are using new tools. And in particular, we are using some of the latest tools in the field of spatial data science. And the field of spatial data science is really fascinating. And I hope I can share with you some of the most interesting developments in this emerging field. Okay, so 3 parts. Why regional development is important, how can we study regional development from outer space, and how regional development in the 21st century is based on research advances in spatial data science. So here we go. So this is one of my favorite videos for introducing the field of regional inequality, first across countries, but also within countries. So I want to just confirm, have you ever seen this amazing video of Hans Rosling? If you have seen this video, just raise your hand. So I want to know how many people have seen this video. Okay, so it seems that few people have seen this video. That's good. So you are going to enjoy this video then. So let's watch this video together. And after that, let's discuss some of the most relevant findings, okay? So in 4 minutes, we are going to summarize 200 countries in 200 years. So it's really a great achievement. How can we understand 200 countries over 200 years in only 4 minutes? And we can do that thanks to the beautiful, thanks to the beauty of data science. And here we go.
Visualization is right at the heart of my own work too. I teach global health. And I know having the data is not enough. I have to show it in ways people both enjoy and understand. Now, I'm going to try something I've never done before. Animating the data in real space, with a bit of technical assistance from the crew.
So, here we go. First, an axis for health,
Mr.
life expectancy, from 25 years to 75 years. And down here, an axis for wealth, income per person, $400, $4,000, and $40,000. So down here is poor and sick, and up here is rich and healthy. Now, I'm going to show you the world 200 years ago, in 1810. Here come all the countries. Europe brown, Asia red, Middle East green, Africa south of Sahara blue, and the Americas yellow. And the size of the country bubble showed the size of the population. And in 1810, it was pretty crowded down there, wasn't it? All countries were sick and poor. Life expectancy were below 40 in all countries. And only UK and the Netherlands were slightly better off, but not much. And now, why start the world? The Industrial Revolution makes countries in Europe and elsewhere move away from the rest. But the colonized countries in Asia and Africa, they are stuck down there. And eventually, the Western countries get healthier and healthier. And now we slow down to show the impact of the First World War and the Spanish flu epidemic. What a catastrophe! And now I speed up through the 1920s and the 1930s. And in spite of the Great Depression, Western countries forge on towards greater wealth and health. Japan and some others try to follow, but most countries stay down here. Now, after the tragedies of the Second World War, we stop a bit to look at the world in 1948. 1948 was a great year. The war was over, Sweden topped the medal table at the Winter Olympics, and I was born. But the differences between the countries of the world was wider than ever. United States was in the front, Japan was catching up. Brazil was way behind, Iran was getting a little richer from oil, but still had short lives. And the Asian giants, China, India, Pakistan, Bangladesh, and Indonesia, they were still poor and sick down here. But look what is about to happen. Here we go again. In my lifetime, former colonies gained independence, and then finally they started to get healthier and healthier and healthier. And in the 1970s, then countries in Asia and Latin America started to catch up with the Western countries. They became the emerging economies. Some in Africa follows. Some Africans were stuck in civil war and others hit by HIV. And now we can see the world today in the most up-to-date statistics. Most people today live in the middle, but there are huge differences at the same time between the best of countries and the worst of countries. And there are also huge inequalities within countries. These bubbles show country averages, but I can split them. Take China, I can split it into provinces. There goes Shanghai. It has the same wealth and health as Italy today. And there is the poor inland province Guizhou. It is like Pakistan. And if I split it further, the rural parts are like Ghana in Africa.
And yet, despite the enormous disparities today, we have seen 200 years of remarkable progress. That huge historical gap between the West and the rest is now closing. We have become an entirely new converging world. And I see a clear trend into the future. With aid, trade, green technology and peace, it's fully possible that everyone can make it to the healthy, wealthy corner.
Well, what you just seen in the last few minutes is a story of 200 countries shown over 200 years and beyond. It involved plotting of 120,000 numbers. Pretty neat, huh?
Okay, so how was it? Did you like the video? If you like the video, give me a thumbs up. Okay, great. So I like to show this video very often to my students because it highlights many, many important aspects of development. Development is a process that takes time. Development is a process that involves inequalities and differences across countries. Development is also a process that involves differences within countries. And one of my favorite examples within this video is the case of China. And as you can see here, let's focus again in the case of China. China has been growing at a very fast pace. We know that. But what about inequality within China? In particular, this video highlights the importance of going beyond the average. If we go to China, we can find places like Shanghai. Like in this video, Shanghai is as developed as Italy. So that's very good for Shanghai. But within China, there are other regions that are as poor as Pakistan, and in rural areas, they are as poor as Ghana. So this is really fascinating because if we go to China, we can find developed places similar to Italy, but we can also find underdeveloped places similar to Ghana. So this is telling us something very, very important, that within countries, there are large development differences. And I think all of you know that because in Indonesia, there are huge differences across islands. If you are lucky enough to be born in Jakarta or in Java, your life is much, much more different than the life of somebody who was born in Papua, for instance. These differences are really big. And as a scientist, the first thing that we need to know is how large or how big are those differences. Then we want to know how those differences are changing over time. And then we want to know why those changes are happening. So the field of development is really fascinating. But within development, studying subnational development, like in this example, subnational development in China is also really fascinating because the question would be, why some regions like Java or Jakarta are much more developed than others? Why is that the case? Can we understand inequality? And can we use a scientific approach to understand development? And what do I mean by scientific approach? In this example, there is one key element that is going to bring your attention. And that element is data. Data is very important for scientific research, because I can tell you, look, there is a lot of inequality in China. There is a lot of inequality across countries, but that can be my opinion, and maybe you don't believe me. But if I show you the data, if I show you the evidence, like this picture, look, in one picture, you can see how large is the difference between Shanghai and Guangzhou. So these differences, when you bring data and you have data supporting your argument, that is more powerful. And development today requires more data than before. If we have more data, we can make better decisions. Data is an important component for understanding development. Data is an important component for designing development policies. Without data, we might end up in a useless debate only depending on subjective opinions. And don't get me wrong, opinions are important, but data can help us organize our discussion. Data can help us find solutions. So data is important, as you can see from this video. Data can also be beautiful. This video is showing you an animated graph, and I think you've seen many boring graphs that are poorly designed, black and white, and they are difficult to understand. But in this video, you saw an animated graph that is very engaging, that is very exciting, and it's also very beautiful. This is another important research skill that I push my students to develop, and that skill is data communication or communication in general. It's not enough to have a good idea if you cannot sell that idea. It's important to sell that idea in the most engaging way possible. And to create this beautiful graph, to create this animated graph, they used 120,000 points. Well, that's a lot of data. So the question is, are you ready and are you able to handle such a large data set? Are you getting those skills for data management? Are you getting the skills that are needed for data visualization? Can you communicate your findings in an engaging way? All of us work in the business of creating ideas. So we create, especially scientists, we create ideas that hopefully have an impact in the world. And those ideas hopefully can be useful for development policies. But creating the ideas is not enough. We have to sell the ideas. We have to show people that these ideas are important, that these ideas are interesting, and also in this case, that these ideas are beautiful and engaging. Okay, so one of the key takeaways from this lecture is that data is important for development, that we need to get good data, but getting the data is not enough. We have to present the data in the most engaging way possible, like in this video, okay? Well, okay, so if you think that data is important for understanding development, what kind of data can we use to understand subnational development, development across cities, development across provinces? Where can we get that data set? So that is the next question. If you think that data is important, first of all, where can we get it? And for how many years? Remember, in this video, they have 200 years of data. Can we get 200 years of data for Java? Can we get 200 years of data from Papua? It's very difficult to get such a large data set in developing countries. So what can we do? Where can we get the data if it's so difficult to get? So I was having that puzzle myself when I was beginning my career as a regional development economist. I was convinced that regional development is important because I was lucky enough to be born in the capital city of my country. But when I go to the countryside, I immediately see poverty, and I can see how poor people are in rural areas. So even within my country, I used to see large disparities in development. Then the question was, can I measure those disparities? I think those disparities are big, but can I actually measure that? Where can I get the data? So that was my first question. Then let me tell you what I found. It was difficult to get data from developing countries. And I also had a second goal in mind. I wanted to compare the subnational region of country A with the subnational regions of country B. Example, I wanted to compare the development of Papua with the development of Nagoya. So I know that there is a gap, and I think you already have that impression, but can we measure that gap? What is the development gap of the average person who lives in Papua and the average development of a person who lives in Nagoya? We think it's large, but can we measure it? Well, this is even more complicated because think for a moment. In macroeconomics, it's already complicated to compare Japan and Indonesia. Why? First of all, to compare the income of Japan with the income of Indonesia, we have to measure both incomes in the same way. And in economics, somebody can tell you that at the beginning, we might try to use exchange rates, right? So we can use the exchange rate to convert the income of Japan in dollars, and then we can convert the income of Indonesia in dollars, and then we can compare dollars with dollars. But then if you took a macroeconomics course, you will learn that the exchange rate has its own problems. The exchange rate has its own fluctuations, and central banks and other local economy situations can affect the exchange rates. So the exchange rates can have some problems. So that is why if we want to compare the income of Japan with the income of Indonesia, instead of using standard exchange rates, we use PPP exchange rates. And the World Bank has a large project on generating PPP exchange rates, so we can try to compare the income of Japan with the income of Indonesia. But even in that case, PPP exchange rates are not perfect. And these PPP exchange rates are for the entire country. It's essentially an average for the entire country. And you will understand immediately that Papua is not equal to the average of Indonesia. So here we have a problem. How can we compare Papua and Nagoya if they are not equal to the average PPP exchange rates that we can get from the World Bank? So this is another problem. Comparing countries is already complicated. Comparing the regions within countries is even more complicated because prices are different. Prices in Papua are different than prices in Java, for instance. Prices in Papua are different than prices in Nagoya. Prices are different. And getting regional prices, it's a very complicated task. So here I'm telling you that at the beginning, doing research in regional development is complicated because we don't have enough data, or we do not have the data that we would like to have. Regions are very different, even within countries. It's very difficult to compare Nagoya with Tokyo because Tokyo, prices in Tokyo are very expensive. If you someday you go to Tokyo, prices are very high. In Nagoya, prices are a little bit less expensive than Tokyo, but there are regional differences in prices, okay? So here we have a challenge. It's difficult to get data, and it's much more difficult to get data of subnational regions. So how can we solve this problem? And I'm gonna give you the beginning of an answer in the following slides, but keep that question in mind. I want to compare Papua with Nagoya, but it's very difficult to compare because prices are different. What can we do? That's the open question. Then another question is, can we use macroeconomic indicators like national GDP, unemployment, inflation to understand regional development? Are these macro indicators enough? And the answer is no. I started my career as a development economist as a macroeconomist. And macroeconomics is great. It's a great field, but it was not that useful for the questions that I had. Remember, my question was, I want to compare the economy of Papua with the economy of Nagoya. And national GDP was not helping because Papua is not equal to national GDP, because Nagoya is not equal to national GDP of Japan. So macroeconomic indicators were not enough. Okay, then what about microeconomic surveys? Okay, so microeconomic surveys and field studies are very popular. Maybe I can go to Papua myself and I can do a field study. Maybe I can talk to the people. Maybe I can conduct a survey and I can conduct another survey here in Nagoya. Okay, that is a microeconomic survey. Is that enough? Do you think that's enough? Well, remember, what do I want to do? I want to compare Papua and Nagoya over many years, right? Over many years. Remember, in the video, Hans Rosling is studying 200 years. So is it possible for me to conduct a survey for 200 years or at least 10 years? It's not possible. It's not enough. So microeconomic field studies is not enough for the type of analysis that I want to do. Remember, I want to compare Nagoya and Papua over many years. And doing that with field studies is going to be very time consuming, it's going to be very expensive, and it's not going to be manageable. So microeconomic surveys is not enough. So here we have a problem. A standard macroeconomic approach is not enough. Standard microeconomic approaches are not enough either. So can I ask you, what is in between macroeconomics and microeconomics? So I'm sure all of you already took microeconomics 1, microeconomics 2. Probably some of you took macro 1, macro 2, macro 3. That's great. That's what I took when I was a student. But there is something in between microeconomics and macroeconomics. What is in between these two things? Did you take this course? Is this course available in your university? It was not available in my university. I had to learn this later in graduate school. What is in between microeconomics and macroeconomics? Regional economics. Regional economics is a beautiful field that is taking insights from both microeconomics and macroeconomics together. How? We can aggregate the microeconomic findings to the meso level. And then when we have meso level units like regional economies, like provinces, like cities, like villages, like towns, like neighborhoods, at this aggregated level, we can use some macroeconomic frameworks. So I like to summarize regional economics as a very exciting field in which macroeconomics meets microeconomics, and they talk to each other and they build on top of each other. And that is a fascinating field. Okay. Next, let me go to the next slide. Where can we get data on regional development? So remember, I want to compare Papua with Nagoya, but there is no data. Fieldwork is not enough. Macroeconomic data is not enough. So this year, my graduate school was celebrating its 30th anniversary. And we organized a series of webinars and panel discussions. And one of those sessions was on studying development from outer space. Okay, and I apologize for the announcement. So there is an announcement here in my university. So sorry for that additional noise, but hopefully you can still listen to me. Going back. So this year, my graduate school celebrated 30 years. And in one of the sessions that we organized, we wanted to understand what can we do in the next 30 years if we want to keep studying development. In particular, we want to understand development within countries. What tool should we use? What data should we use? And one of the first options to study development within countries is data from outer space. In particular, satellite data. And this session was trying to introduce how economists can move from surveys to satellites. Okay, don't get me wrong, surveys are still interesting and important, but in addition to the common surveys that economists use, can we use satellites to understand economic development? That is what we discussed in this panel, and I invited some of my research collaborators and also some of my students that are trying to include these new data sources like satellites to understand development. Okay, and that is my next point, that today we are living a revolution of data. We have more data than before. And one of the new data sources that we have at our disposal is not coming from surveys, it's coming from satellites. And in the following video, I'm going to show you how satellite images can open your eyes and help you understand development. Okay, so in this second part, I want to talk about studying regional development from outer space. And when I say from outer space, our measurement instrument is going to be the sensors of satellites. Okay, so if you liked my previous video, I think you are gonna love this other video. So usually when I teach, I know that people get tired. If you listen to the same person for more than 20 minutes, people naturally get tired. So what I usually do, I bring some small videos that have a very important message, and then I discuss that message with my students. So I am telling you that satellite data is very useful nowadays for understanding regional development and regional inequality. In particular, now we can use satellite data to compare Papua and Nagoya. And that was my previous challenge. Before, I couldn't do that. But if I use satellites, now I can. Let me show you how.
How much can a single picture tell us about ourselves? This is a composite image of several satellite photos. It can help us better understand the current developments and conflicts underway. The amount of light pollution is most severe in heavily populated areas, as well as in regions of high prosperity. In Europe, the Benelux region and the densely populated Po Valley are so bright that the individual towns blend into one big sea of light. Especially in the Arab world, the extraction of oil creates bright lights from the flaring of gas. And in Africa, you can trace the path of the Nile River, which, as the lifeline of Egypt, attracts civilization and is filled with commercial boats. In the mostly uninhabited regions of Western Australia, the satellites could even capture lights from wildfires that occurred over a span of 22 days. And in Asia, the Indian subcontinent is clearly standing out. Nearly 20% of the planet's population lives here. And the rapid population and economic growth can be seen by comparing the area from how it looked in 2012 and then again in 2016. However, it's just as interesting to look at the regions where there is no light. The Syrian civil war, which has wiped out hundreds of thousands of lives, has darkened the country. Due to the ongoing fights, the electrical grid is only partially available and the power supply is poor. Aleppo, the largest city in Syria, is considered an important cultural place. The old town has been a UNESCO World Heritage Site since 1986, but the war has almost completely destroyed the historic city. The darkening can also be observed in Raqqa, which has long acted as the de facto capital of the terrorist Islamic State. When we see a city darken in these images, it shows the annihilation of a place and its history, and ultimately the end of many human lives. These black pixels in such an image can say a lot more than the lit ones. This also applies to the Korean peninsula. While South Korea is brightly lit, North Korea is almost completely black. The metropolitan area around the capital of the South, Seoul, now has more than 25 million inhabitants. The population density here is twice that of New York City and 8 times larger than that of Rome. Also, the waters surrounding Korea are brightly lit from the numerous fishing boats off the coast. According to the UN Convention on the Law of the Sea, there are clear rules for how far off the coast a country may explore its resources. Additionally, there are several agreements between countries that regulate fishing. This creates odd shapes and perfectly straight lines, bringing to light the absurdity of dividing our planet into arbitrary legal zones. All these lights from South Korea and the waters that surround it stand in stark contrast to the north, where only the North Korean capital Pyongyang stands out a bit. North Korea's energy infrastructure is obsolete and power shortages are frequent. While South Korea is easily accessible, much of what happens in the north remains in the dark. And the strictly guarded border dividing both nations, the DMZ, is clearly traceable. This image may be the most impressive illustration of how big the impact of more than 70 years of division are. But the map also teaches us the long-lasting impact such separations can have, even those that have already been overcome. At the time of the Cold War, Germany was separated into East and West, and the city of Berlin was divided as well. And as a result of that, its city lights still appear in 2 different colors. The western part of the city was cut off from the rest of West Germany and relied on gas lamps because it wanted to be independent from a possibly failing power supply. Although Germany has been reunited since 1990 and this separation has been overcome for more than a quarter of a century, it can still be seen from space. This image points to the global challenges posed by the steadily increasing world population. And while man-made borders cannot be seen during the day, the lines of political origin become apparent at night, but appear all the more absurd and artificial. When viewed during daylight, the human influence on our planet is less obvious. But this single image highlights the social divides and political strife from both past and the present. Was cut off from the rest of West Germany.
Okay, so what do you think? Did you like this video? Please give me a reaction if you like this video. Okay. So what is the key message of this video? What can we learn from this video? I think we can learn a lot of things. So if you're a researcher, it's telling us that pictures like satellite images can give us new information. Pictures like this difference between West Berlin and East Berlin are really informative. So if we wanted to compare East Berlin and West Berlin, but we do not have data, we cannot go to the field, or macro data is not enough, we can use satellite data to understand the regional differences between these two places. One of the most fascinating examples of this video was Syria. Okay, so Syria, what happens if the country that you want to study is not able to give you statistics, essentially because they are under conflict. So if a country is under conflict, they are not going to give you statistics. You cannot go to the field. You cannot ask questions to the people. But what can you do? If you really want to understand what is happening in that country, but you cannot go, the satellite is always there. And these satellites provide public data, data that you can use, data that you can interpret, and data that you can analyze. And this is really a new form of doing research that goes beyond simple analysis of tables that you can download from the World Bank website. This goes beyond field surveys or online surveys that you can collect. This is another perspective to understand development. I'm not saying that this is the best perspective. I'm not saying this is the worst perspective. I'm just saying that this is an alternative. We can understand the world using satellites. And you think, well, of course, I mean, we can understand the natural world using satellites. That's why I understand the weather. And that's why I know that I have to take an umbrella. But this goes beyond the natural world. Satellites can give us insights related about human development, social insights. Like in this case, all of these lights are human-made. So humans are creating these lights. And if we understand the patterns of these lights, we can also understand how humans are evolving over time. Okay? So many people thought that working with satellites is only for other type of scientists, like natural scientists or physicists or people who study astronomy. From now on, you understand that satellites can also be used by social scientists like all of you. Satellites now are reachable for all of us. We only need a little bit of background on geography. We only need a little bit of background on programming. But after you achieve this minimum background in geography, after you achieve this minimum background in programming, a new world will open for your research possibilities. And that is what I want to emphasize. In my work, I mostly study regional development using satellites. It's not the only source, but it's a useful source. And when I was a student like you, I bought a notebook. And in the cover of that notebook, there was this picture. And when I was an undergraduate student like you, I thought this picture looks cool. I like blue. And I like the combination of blue with this light yellow. And I bought that book because the picture was nice. But 15 years later, I am using this picture, not because it looks nice, because this picture gives me new data. What kind of data? Big data. This is a huge data set. So if you know a little bit of photography, you know that if you take a good picture takes a lot of space in your camera, many megabytes, right? So if you really want to take a good picture, the picture can be many, many megabytes. But do you have any idea the size of this picture in terms of megabytes? Can you guess? Do you think that this picture can fit in your smartphone, that you can take this picture with the smartphone? Of course, you can have a simplified version in your smartphone and it looks nice. But if you want to get access to the original picture, the picture with the highest resolution, that picture, the size of that picture is on average 10 gigabytes. Only one picture like this, 10 gigabytes. Can you open a file of 10 gigabytes in your computer? Well, it depends. So how big is your computer? So when I say big data, what does big mean? Well, in this example, this picture for 1 year, or at least for one take, is 10 gigabytes. Can you open it in your computer? Well, in many laptops, you cannot open this because many laptops, they have only 4 gigas of RAM memory. If you buy a MacBook Pro, for instance, then you can extend the RAM memory to 16 gigas. And if you have 16 gigas in your memory RAM, then you can open this picture in your computer. So essentially, this data set is large. The picture is large because we need high quality images because we are going to zoom to understand that. So first of all, this is big data. The other important component is how to translate a picture like this into a table. Because if we want to do a statistical analysis, we usually need tables, the X variable, the Y variable, and so on, right? So this is another skill that we need to learn if we want to do research in this field, how to translate pictures like this into an Excel spreadsheet. And to do that, you need to learn some basic programming. You can do this in a programming language like Python, or in another programming language like R, or in another programming language like Julia. So this skill is needed for this type of research, but it's not that complicated. Okay? And in fact, if you go to my website, you will find a tutorial on how to translate these pictures into tables. And if you are motivated enough, you can do this for your own purposes. But look at the technology that we are using and look at the mathematics that we are using. How can you translate a picture into a table? So I have a question for all of you. Did you take the class called linear algebra? So give me a thumbs up if you took the class called linear algebra. So what do I mean by linear algebra? It's the algebra of matrices. So you are working with matrix, right? And I remember when I was an undergrad, linear algebra was very important for economics because matrices are useful. So did you take linear algebra, or do you know the algebra of matrices? If you know what linear algebra is, give me a thumbs up. Okay. So my advice is linear algebra is very important. Okay. So if you want to do this type of research, a basic understanding of linear algebra is needed, because how can you translate a color into a number? For instance, this is dark blue. This is strong yellow. So what you need to do, you can try to understand that if it's yellow, it's going to be a high number, like 63. And if it's dark, it's going to be a low number, like 2. And each of these dots, each of these pixels, it's going to be organized in a matrix form. So all of this picture, when we zoom in, is a collection of the small pixels, like the pixels that you take with your smartphone in any picture. And each pixel has a number. The pixels with high numbers are telling me that lights are high. The pixels with low numbers are telling us that lights are low. So essentially, if we zoom in, this picture is a matrix. And what we need to do is we can sum up the numbers of those that are in that matrix to transform the matrix into a table. And if I do that transformation from the picture to a matrix and from the matrix to a table, then I have data that I can use, okay? And that is a very important skill. Learning how to program is a very, very important skill, not only for regional development, but also for economics. Any economist needs to learn how to program. Not only one language, probably most of you, the first language, the first statistical software that many economists use is Stata. Have you ever used Stata? If you use Stata, give me a thumbs up. Okay. Stata is good. Stata is great, but it's not the only game in town. Okay, Stata is great. It's a great place to begin, but for this type of analysis, Stata is not enough. Stata is not going to transform the picture into a table. Stata doesn't have those capabilities. You need to go beyond Stata. In my case, I use Python programming to translate this picture into a table. And then I can use Stata for my analysis. So this is important because it's telling you that in the 21st century, economists need to diversify their skills. Stata is good, but it's not enough. What would be the next programming language that you can learn? What would be the next skill that you need? It's my own opinion, but I would say Python is a great programming language. Python and or R. It really depends on what do you want to do. If you are more interested on statistical methodologies, that probably R is what you need. But if you are more towards computer programming algorithms, like this algorithm that translates pictures into tables, then Python is very helpful. Okay, so learning how to program is a very important skill that economists know that. Economists use Stata very well, but in many cases, that might not be enough. If we have other options, it's important for us to learn how to use other programming languages. When my students come, I always like to tell them that learning how to use statistical softwares and programming languages is like learning how to use your 5 fingers. So you have 5 fingers, right? And one of the first programming tools or statistical analysis tools to use is Stata. After that, or in parallel, I push my students to learn Python. Python is really important. Then, depending on what they need, they also learn how to use R. And then they also try to learn, some of them, they try to learn MATLAB. Others try to learn Julia, okay? So there are these very important programming languages that have their own features. And I'm not telling you one is the best, one is best and the other ones are not so good. You cannot compare the usefulness of your 5 fingers. You use all of your fingers depending on the task that you have. For some tasks, maybe 1 finger can be enough. I've seen some people who can type very well with 1 finger, and that's good. So if you can type with 1 finger, that's great. But I've seen other people who type very well with all of their fingers. And to me, learning how to program and knowing many programming languages is like using all of your fingers. And that is a question that I have for all of you. Do you know how to learn these programming languages? What would be the next step for you if you want to learn these tools? Okay, and I will give you some hints at the end, but at the moment, I'll let you with that question. Okay, so the video that I show you is a video of satellite data, and the images are taken at night. And that's great, but we can also take pictures using satellites during the day, right? It's not only pictures at night. I can use satellites to take pictures during the day. What can we learn if we use satellite data during the day? And in this video, you will see a very interesting example on daytime images. Daytime images can also be very useful. So here we go.
Until the 70s, the Amazon had only 1% of deforestation. We now have almost 20% of the Amazon deforested, and we had a strong increase of illegal deforestation inside indigenous territories and other protected areas. ISA is a Brazilian NGO supporting indigenous peoples and traditional communities in managing their territories. What happens is that there is a lot of uncontrolled activities in the region that occurs in an illegal basis. We identify the illegal activities, we bring the proofs together, and we make the formal denounce.
So we have access through Google Earth Engine to tons and tons of data. So we know how much has happened within indigenous territories, and it would be impossible for us to download this and to work local on our local machines. So we use the Google Cloud platform.
Kamikia is one example of one of these indigenous guys that is working for the benefit of their communities by making pictures and showing people what's going on there.
Recentemente, o desmatamento avançou muito próximo à nossa casa. Quando eles mandam alguns dados que eles veem via satélite, e sempre procuro ir no local para fazer filmagem de perto e fazer imagens aéreas com drone.
The satellite images together with the drone photographs Kamikia does. That strengthens the denounce that you can do by showing where it was happening and what was happening. It's very important to be strong in our communication, and the support from Google helped us to improve our work.
The Google Ads grants is a great chance to be heard and to stand out.
It's something very powerful and very important to our organizations.
And this technology will one day be able to put an end to illegal deforestation.
That strengthens the denounce that.
Okay. So what is the key message of this video? This video is telling you that you can use satellite images during the day to understand the evolution of deforestation. Deforestation is a very important development issue. If there is more deforestation, we are going to have problems with the sustainability of our environment. We want to have many trees. We want to have healthy trees. But if we are losing our forests, the sustainability of our environment is under attack. So how can we monitor the evolution of sustainable environments? How can we monitor the evolution of healthy forests? In this example, you learn that daytime images can tell us where and when a change is happening. And that is a very important component of development, because we study development as the change of some dimension. In this case, is the sustainability of the forests. And if the forests are disappearing, that is going to give us a development problem. So we want to know when and where the change is happening. And satellites give us that additional information. Doing this with surveys, doing this with macroeconomic indicators is not feasible. It is much more efficient to do this with satellites. And of course, I'm not saying that this is the only source of information, but this is an additional alternative that we can use. Okay? So we learned that satellites at night, they provide useful insights on human evolution in terms of lights. We learned that satellites during the day tell us how nature is changing because of human action. So we can try to design a development policy that tries to handle these deforestation problems. Okay? So satellite images are a new game in town, are a new opportunity that many researchers in social science can start thinking and can start using with some investment in their education. Okay? You need to invest in your education to learn these new tools, these tools of big data, these tools of spatial data science, these tools of Python programming. Okay? So we need additional investments, but as any economist know, we need to invest where it makes sense. If you see that the return on investment is high and profitable, then you invest. And at least based on my experience, learning these technical skills has been a great investment for my understanding of social development. And I hope some of you can also be motivated enough and start learning how to program in Python, start learning what is geographical information systems, start learning how to communicate with satellites, how to use satellite data, and so on. Okay, so at this point, usually students ask me, okay, I'm motivated enough, I want to begin, where should I begin? So I want to start communicating with satellites. I want to use satellites. Okay, so one of the most convenient tools, I'm gonna call it a very useful tool to begin, is the Google Earth Engine. Remember, in the previous video, they were saying, thanks Google for creating this, thanks Google for creating this. What are they talking about? Well, they are talking about the Google Earth Engine. So what is this? I told you that working with satellite images is not easy because satellite images are very big and our small computers sometimes cannot handle such a big type of data. So Google made a very helpful investment. They started collecting many pictures from satellites, many pictures from satellites, and they saved all of these pictures in the servers of Google. So you can, if you want, you can access the servers of Google and study the images that they have been collecting so far. That means that you do not have to download the images in your computer. That's good, because remember, our computers are small, the computers of Google are big. So we can use the computers of Google to understand these large data sets. So that is great. So at a very simple level, Google has been collecting these images for us. Well, thanks, Google. But Google has done something else. Google has created a system to analyze those images. So they are not only storing the images, they also created a platform to analyze the images. So you can compute the statistics in the cloud. And this is another revolution of data science, which is cloud computing. That instead of using our small computers, we can use a larger computer that is in the cloud, a computer that is more powerful, a computer that has all of the data, a computer that has all of the software already installed. And do you know what's the best thing? It's essentially free. And well, if you are an economist, you know that nothing is free, but at least if you want to use this tool, if you have a Google account, like a Gmail account, and that's kind of the price that you have to pay, you have to be a Google user. But if you are already a Google user, you have access to this additional tool called the Google Earth Engine, okay? Which is very, very useful. Do you want to know how useful it is? Okay, so let's watch this video.
Ask the average person for the biggest cause of global warming, and chances are they won't say trees, but in fact, tropical deforestation. the loss of the healthy forests that absorb carbon dioxide accounts for more greenhouse gas buildup than all the cars, planes, and other vehicles in the world combined. Today, there's a growing consensus in favor of protecting the world's forests. But for these sustainability projects to succeed, tropical nations have to be able to accurately observe and report on the changing state of their forests, often in remote parts of the world. Every day, Earth-orbiting satellites gather incredible amounts of environmental data. But storing and publishing this information is an enormous task, and as a result, much of it is never seen by the people who need it most. That's why we built Google Earth Engine. Earth Engine is an online environmental monitoring platform that makes available to the entire world a dynamic digital model of our planet, updated daily. We've started by publishing online for the first time the complete archive of more than 25 years of historical Landsat imagery for the planet's tropical regions. This archive gives dozens of countries access to the most current data about their forests. Earth Engine also gives scientists and officials high-performance tools to analyze and interpret detailed environmental data, from rainforest changes in the Amazon to water resources in the Congo. Calculations that used to take hours or days to perform can now be done in minutes or seconds. Earth Engine is also empowering local communities in the developing world. The indigenous Suruí tribe in the Brazilian Amazon, for instance, is using satellite imagery in combination with smartphones to monitor and protect their rainforest. Think of Google Earth Engine as an environmental watch program in which everyone can participate. Local citizens, governments, scientists, donors, the media, anyone who's interested in what's happening to the natural world. The work matters. Today's environmental challenges are complex and daunting, and we all have to do our part to meet them. To that end, we'll continue developing this platform, adding more data, more tools, and new applications. We hope that over time, Google Earth Engine will help reduce tropical deforestation, empower developing nations and local communities, and contribute to a more informed understanding of our planet. If you'd like to learn more, please visit us at earthengine.googlelabs.com. We hope you enjoy exploring.
Okay, so the Google Earth Engine is there. You can use it. And if you are lucky enough to know a little bit of Python programming, the Google Earth Engine has an API for Python programmers, but it also has an API for JavaScript programmers. So essentially, the tools are there. But to use those tools, we need to make an investment. And the investment is we need to learn how to program in Python or in JavaScript. And I would say, if you have to start somewhere, I would say Python is the best place to start. As a programming language, Python is very intuitive and it's very easy to learn. Okay. So I just finished introducing how to study development from outer space. Essentially, now you have satellites that can do an important task for you. Satellites can monitor where and when something is happening. For example, satellites can monitor when and where deforestation is happening. Satellites can also monitor when and where lights are changing. If there is a crisis, what happens with lights? So it has been shown in many interesting research papers that the COVID crisis has generated a reduction in lights. Instead of people going to work, people work at home. And on average, there is less light consumption if they stay home. And that is an application of satellite night lights analysis for the COVID crisis. But there are many other applications. So the moment you use lights, it's because you are producing something. You need lights to use a computer. You need lights to work in a factory. You need lights when you go to the dentist. Lights are really related to human activity, economic activity in particular. So when we see the economy evolving, when we see the economy growing, we also tend to see improvements in light availability. And satellites can tell us when and where that is happening. It is because of this type of technologies that now I can compare Nagoya with Papua to some extent, okay? So that was my key message number 2. In my job, I study regional development from outer space. And this might sound crazy to some people, but it's really fascinating. You discover insights that are very difficult to understand from other perspectives. So development from outer space is a fascinating field that, at least in our graduate school, we are starting to introduce to our students. Yes, we go to the field, we do field surveys. Yes, we use macroeconomic indicators. But in addition to that, we are now using satellites to understand the process of regional development. Okay. Now, I just show you very nice figures, very nice graphs and videos on regional differences. But all of these results, they have to be supported by something. Science is supported by the progress of previous scientists. So science is an evolutionary effort. So humans evolve, they create, they discover things, and over time, humans build on top of previous discoveries. This accumulation of knowledge is how science evolves. And now, the moment you decide to get a PhD is a moment very special in your life, because you decide to become a professional scientist. Before going to the PhD program, I was an engineer, and that was my main job. Okay, I went to the university to be a commercial engineer. That means understanding a little bit of economics, understanding a little bit of production, but my profession was an engineer. But then when I went to graduate school and I decided to become an academic, the PhD life is a choice of discovery, which is fascinating because you build on the previous discoveries and you can see how other people work and how tough it is for them. But once they discover something, you can build on top of those discoveries. And in science, there is this beautiful quote that I really like, which is summarized by standing on the shoulders of giants. Have you ever heard of that quote? Standing on the shoulders of giants. So now I would like to tell you that regional development is standing on the shoulders of spatial data science. Regional development is standing on the shoulders of spatial data science. What does that mean? Well, this is one of my favorite quotes. Have you ever heard of this quote? Have you ever seen this somewhere? It's by Isaac Newton. And it's really insightful. If I have seen farther, it is by standing on the shoulders of giants. So if you are a scientist, this quote is in your heart, because this is how you move forward. You do not move alone. You build on previous discoveries. You contribute to previous discoveries. And it's because of the previous discoveries of the past that you can see farther. If we want to translate this quote in plain English, this quote is telling you that discovering the truth is done by building on previous discoveries. And this is the life of a scientist, that you try to build something new and exciting, but whatever you are building is not on the air. Whatever you are building is on the shoulders of the previous giants that came before you. And when I say the previous giants, of course, there are great scientists in the world, but the shoulders that you use are also the shoulders of your professors. Your professors are going to give you your first tools to understand the world of science. And you are standing on the shoulders of your professors to understand your own field. But it's not only the shoulders of your professors, it's the shoulders of other people, it's the shoulders of other scientists. And in regional development today, we are standing on the shoulders of spatial data science. What is spatial data science? Let's start with a simple definition. What is data science? Have you ever heard the term data science? So give me a thumbs up or any reaction if you heard the term data science somewhere. Okay. Okay. Well, thank you very much. So one of the simplest definitions of data science is by Drew Conway, and his definition is summarized in this Venn diagram. Data science is the intersection of domain knowledge, coding, and statistics. Domain knowledge, coding, and statistics. Or instead of coding, you can call it computer science if you want. Or instead of statistics, you can call it mathematics if you want. Okay, but just to keep things simple. Domain knowledge plus coding plus statistics equals data science. So what is domain knowledge? Domain knowledge is your field of expertise. If you are an economist, so your domain knowledge is economics. If you are a macroeconomist, your domain knowledge is macroeconomics. If you are a labor economist, your domain knowledge is labor economics. So you have some background, you have some basic theories. You see the world from a particular domain. That domain can be economics, can be biology, can be geography, can be politics. You have your domain knowledge. Now, the typical way of doing research is to combine domain knowledge with the statistics, right? Because one way to write a scientific paper is to combine statistical results with a theory. And that would be here. So if, for instance, you use Excel to create a table, a statistics table that is here, and then you use your economics knowledge to understand the meaning of that table, if you combine economics with Excel type of statistics, then you are doing research here. Okay, but what happens if you use Python instead of Excel? Okay, then you are here, because to use Python, Python is not a clicking software. You have to code in Python. Okay, and if you are combining your coding skills with your statistics skills and your domain knowledge skills, then you are a data scientist. And of course, the combination is complicated because nobody's an expert in everything. Okay, but we try to combine, to some extent, our knowledge of economics with our knowledge of statistics, or econometrics if you want, with your knowledge of computing programming. Why is this important? Because you cannot use Excel to translate satellite images into tabular data. You need to use other tools like Python, like Julia, like R. So you need other coding skills. So when data becomes more complicated, we need to start looking for other tools. And it's very likely that those tools are based on a programming language. Okay, so this summary is telling you that if you want to be a data scientist, you need to diversify your skills. Having a diversified portfolio of skills is important. If you want to take opportunity, if you want to take advantage of new opportunities, having diversified skills can be very helpful. And having the skills of a data scientist can be very important. Okay? Okay, so this is what data science is. What about spatial data science? Well, Spatial data science is the combination of standard data science, the graph that I showed you before, with geographical information science, GIS. Have you ever heard the term GIS before? If you heard it, give me a thumbs up or a reaction. Okay. GIS is what you use at a very, very simple level. GIS is what you use when you open Google Maps. So if you've ever used Google Maps to go from A to B, that Google Maps is a GIS technology. Okay, it's telling you the geography from a computational model. It's a computational representation of a geography. And that technology, that GIS technology, the maps that you use can be very useful to understand development. And this is another skill that we try to foster in our students, to foster with our students here. Students need to understand the geography of their study places. If they want to study development in Bolivia, for instance, they need to understand the geography of Bolivia. And they will know that in Bolivia, there are highlands and there are lowlands. And these geographical differences have consequences. Consequences in terms of infrastructure. Is much more costly to build, for instance, a subway if you live on the mountains, and it's less costly to build a subway if there are no mountains. So geography is an important component of development. But how can we understand geography if we are not geographers? At a very simple level, all of us are geographers. All of us use maps in our lives. Without maps, we can get lost, or it is because maps that we become more efficient. And without knowing, every time you take your smartphone or every time you use a Google map, you are using a geographical information system. And what we do in spatial data science, we combine GIS with standard data science. Can I, then you might ask, can you give me an example? Where can I see an example of this spatial data science? Okay, let me show you a video. And the title of this video is, Can a Billion Maps Save the Planet? Okay, mapping or mapping technology, GIS technology, can be very important for understanding and for solving development problems. So let's watch this video together.
It's all happened here. Everything we've ever known, done, loved, took place on this drifting, spinning ball that's our home. It's where we learned to provide, nurture, protect, thrive. And yet,
wildfires are scorching the West Coast, leaving behind a path of death and destruction.
15 inches of rain this morning.
The waters keep rising, and according to the National Weather Service,
our very success now threatens our future. Today, our greatest challenge is to learn how to grow while sustaining what sustains us. Your understanding, your science, your work are the solution. You have the power to see patterns and relationships and show us how everything and everyone are connected. You have the power to transform how we produce and consume, build and maintain, unite and strengthen, heal and nurture. You can help us see that we can no longer live apart from nature, but must live as part of it. Today, geography matters more than ever. The geographic approach, your work, and the billions of maps you make are essential for creating a more sustainable future.
Okay. So I want to take away one key message from that video. And that message is that you have the power to see patterns and relationships. And that power can be very helpful to understand and to foster sustainable development. What kind of patterns can you see in the data? Well, every time you take your smartphone and you look for an address, you try to find a pattern from your location to your destination, and then you try to optimize the most convenient way of moving from point A to point B. You are looking for the optimal pattern, for the optimal relationship between place A and place B. Humans are very good at identifying patterns and at distinguishing patterns. And in statistics, we use these innate skills to make them more rigorous. We learn how to use regression modeling. We learn how to use other tools to understand relationships. We use statistical modeling to understand relationships and patterns. But what you saw in this video is that geography itself has its own patterns. Geography itself has its own patterns that you can try to study if you have the right tools, like GIS technologies. Okay. And why geography is important? Well, there is one very important law in geography called the first law of geography, which is this one. Everything is related to everything else, but near things are more related than distant things. Waldo Tobler. This is the first law of geography, and it's very, very powerful, especially if you use data to understand the world. It's telling you that if you use data to understand the world, everything is related to everything else. There are many relationships, there are many patterns, but near things are more related than distant things. In some places, the relationship between X and Y can be stronger than in other places. This idea of relationships being stronger in near places is very important. And this is the first law of geography. And this is interesting because when I was learning some geographical concepts, in particular, when I was studying statistical geography, what is one of the first assumptions that you make when you study data? Well, to keep statistics simple, one of the first assumptions is that our observations, when we take a survey, for instance, and we collect the answers, and we do a statistical analysis, one of the first assumptions is that the answers that we get are independent of the other respondents. So if you remember your statistics courses, we assume that the observations are independent and identically distributed. Do you remember that IID assumption? Observations are independent and identically distributed. Have you ever questioned that assumption? Is that assumption useful if we study cities? Do you think that cities are independent, that city A is independent of city B? Well, in this case, the assumption of independence doesn't make sense at all. And we understand that, especially nowadays, because of COVID. When COVID happened, it started in one city and it started spreading in the surrounding cities, right? COVID has a geographical diffusion phenomenon. But if we use our basic statistics, by assumption, what happens to city A is not related to what happens with city B. But in real life, we know that if city B is next to city A and something happens in city A, like COVID, COVID will spread from city A to city B. And this is an important characteristic of the phenomenon that we want to study. We do not need to avoid that. We do not need to assume that regions are independent. On the other hand, we need to take into account that regions interact, that what happens in region A might affect to region B. And this interaction is at the core of spatial econometrics. This interaction is at the core of spatial data science. When you believe that something happens in region A and region B is very close to region A, there is going to be a diffusion from region B to region A. If you believe that diffusion is important, then you believe that spatial data science is relevant. And the first law of geography is there, that the relationship is stronger when you are surrounded by other cities. And if something happens in city B and city A is surrounded by city B, then the diffusion is important. Okay? So the first law of geography is something that I would like you to remember. Many statistical frameworks, they make this assumption that regions are independent, that if something happens in region A, region B is not going to have any effects. And that is simply wrong when we work with regional data. Regional data by construction requires interactions. And one part of my job here is to teach students how to introduce these spatial interactions, which is a fascinating topic that if you're interested, you can explore. But then the question is, how can I explore? Where should I start learning? Can you give me an example of a starting place? Well, if you are motivated by the ideas of this talk, I have a tutorial for you, okay? And this is the first tutorial that I share with all of my students, okay? And in the chat, I'm sending you the link to this tutorial. And of course, in the chat, if you want, if you like these slides, okay, I'm very happy to share these slides with all of you. In addition to the other slides that I already shared, you have access now to all of my slides. If you want to watch the videos again, watch the videos at your own pace. But in this tutorial in particular, this is a tutorial to start your spatial data science journey. And here in this website, I accumulated a collection of video explanations on what is data science. How do we identify our neighbors? What is spatial dependence? What is spatial inequality? Where do we get data? And essentially, all of my students in their first year, or when they are just beginning the master's program, they have to go over this tutorial. And I created this tutorial not only for my students, but for anybody in the world who might be willing to learn, for anybody in the world who's motivated enough to develop new skills. This is an open resource that I try to share with as many people as I can, because I think it's a reasonable introduction to the exciting field of spatial data science. You will learn from the very basics, what is Python? How do I manage data in Python? How do I create maps in Python? How do I create an inequality index? And many other things. So if you are interested and if you liked some of the concepts that I explained to you, and you want to understand the evolution of spatial inequality and the evolution of spatial interactions, here is a tutorial that probably can be useful for you. Okay, so that is my first gift for all of you for taking the time to come here and listen to me. And the other is that if you want to keep learning more, I am the director of the Quarks Network, which is an international network of researchers and students, because one of the goals is to include students who are highly motivated and want to understand the world from a quantitative, regional, and computational science point of view, like the map that you see here. The map that you see here is not just beautiful, but it's insightful. The map is telling you the spatial distribution of lights. Okay, so this is a map of the Earth at night. But then you think of, okay, so if the colors are lights, why the lights have different colors? Well, because the colors are representing the evolution of lights, okay, that they are changing over time. So when the colors are changing, it's because the intensity of the lights are changing too. So here, what you see is not just a beautiful picture, but it's a picture that can help you ask good questions. Where is development happening? For instance, in the US, if you just go to the US, you immediately understand that the east part of the US, where New York is, for instance, is much more developed than the center. But if you go to California, California is very shiny, right? So with one simple map, you immediately see differences in development. Okay, so this is a research network that, in collaboration with my students, we created. Is the Quarks Network. It's an open community for researchers who want to do spatial data science, but it's also open to students. So if you want to know more about it, just go to quarkslab.org and start exploring. And if you have any questions, you can get in touch with me or with any of the members of the network, which, by the way, there are some students from Indonesia already, very good students from Indonesia. Okay, then I would like to say thank you very much. I hope you enjoy the lecture today. And I hope you see the world in a different way, that the world can be understood from a different perspective if we use satellites. Satellites are not perfect, but they are useful. And if we use them in the right way, we can understand something that is just fascinating. It's beautiful, but it's also fascinating. And you can find results that honestly blow your mind. Like, why in this place change is happening so fast, but 100 meters next to this place, change is not happening. Okay, so you can monitor the evolution of development, but you can also monitor the location of development, where development happens. And if we identify the where, sometimes the where can be very informative to understand the why and the how. And when, as scientists, we are usually looking for understanding why this is happening. And some of my experience so far has been the following. If we want to understand why something is happening, sometimes it's very useful to understand where it's happening first. If we understand where it is happening first, we can get a better explanation of why this is happening there. Okay, so Some people say that spatial data science is the science of where, and regional development in the 21st century is the science of where development happens and why development happens there. So hopefully many of you are interested in this fascinating field. And if you want to keep learning more about it, feel free to check my website or the website of the Quarks Network. Okay. So thank you very much. With that said, let me finish my lecture here. Unfortunately, I wish I had more time, but I have to go to another meeting in about 20 minutes. But for those of you who are interested, I already shared this other paper of mine called Regional Convergence and Spatial Dependence using Satellite Nightlight Data. Although there are some technical sections, the first 2 slides are the non-technical summaries that you can read and you can explore. And especially for the case of Indonesia, I have this paper called Disparities in Regional Productivity, Capital Accumulation, and Efficiency across Indonesia. So a part of my research is also to understand and explain regional development and regional inequality in Indonesia. And this paper is telling you that if you want to understand regional disparities in Indonesia, we need to understand the evolution of human capital. We need to understand the evolution of physical capital. And we also need to understand the evolution of the efficiency with which regions use their inputs. So this explanation of development happens when regions accumulate more inputs, and development happens when regions use those inputs in an efficient way is an important story of development that I try to apply in this paper. Okay, but for the sake of time, I would like to finish this lecture at this point, but I'm more than happy to receive questions from you if you have any. Okay, so thank you very much.
Okay, thank you very much, Professor Mendez, for today's mind-blowing lectures. And for the participants, if you have any question, please write it down on the chat box, or you can raise your hand and ask directly by unmuting your microphones. But unfortunately, since Professor Mendez has to leave in about 20 minutes, I believe, we only have maybe 1 or 2 questions for today's session. So please, if you have any question, okay. Pak Faisal Fadli, okay, Pak Muhammad Faisal, please. Yes, you can unmute yourself. Okay. Pak Faisal Fadil, or maybe you can write it down in the chat box. Okay.
Apakah sudah kedengaran, Pak?
Okay, sudah.
Thank you, Mr. Ginindra, for letting me ask a question to Mr. Carlos Mendez. Before that, I would like to give some appreciation to Mr. Carlos Mendez for the wonderful presentation. And I have a question for you, Mr. Carlos Mendez. Is data science, like the satellite data, also are the complement for the survey that we usually do in economic research, especially regional economic research? Thank you very much.
Okay, thank you very much. So that is a very important question. Some people think that when something comes, the previous tools need to disappear because the new tool is much more useful. In this case, I don't think that's true. Satellite data is a complement of survey data rather than a substitute. You can use survey data to study some additional nuance that you cannot get from satellites. Satellites can give you a rough picture about development patterns, but in many cases, that rough picture might not be enough. You would like to complement that first step with a second step in which you can go over the details. So one way of thinking is the following. You can use satellite data to identify where interesting things are happening. And then you can use your survey data to study the details of those interesting things. You can use survey data to understand the nuanced human experiences in those interesting places. So I think it will be very informative if we combined satellite data with survey data. And that is one of the projects that I'm currently working with the collaboration of some Indonesian students that I had in the past. So what we are planning to do is we want to combine some surveys from Indonesia, like the Susena surveys or any other surveys that you have, with satellite data that I have. So we can build a larger data set that includes both survey data and satellite data combined. And this combination can be much more powerful than satellite data alone and survey data alone. So this combination is really useful. And if anything, if it's possible, I will advise combining survey data with satellite data. But I realize that sometimes the combination might not be possible. But if it's possible, it is highly recommended. Thank you for the question.
Okay, thank you very much, Mr. Carlos Mendez. And also, I think that if the data, if a survey data is only way to research, the only way to getting some data for the regional development data, it will be not enough, I think. So combining those two, like the satellite data and also the survey data, I think it will be really complementary between the two, I think.
Yeah, I agree with that. Complementarity is very important. And nowadays in science, a very important trend in science is interdisciplinary science. So when you start a research project, if you have a collaborator who's an expert in geography, and you have another collaborator who's an expert in computer science, and you have another collaborator who's an expert in engineering, data science and spatial data science in particular allows you to integrate different people, because different people have different backgrounds. Some of us have more experience on programming. Others have more experience on understanding economic phenomenon. Others have more experience on understanding geographies. So an important door that satellite data opens is the door of interdisciplinary collaboration. Because the moment that you start using satellite data, you need to understand the geography of the country very well. Where are the highlands? Where are the lowlands? Where do we see hydraulic or temperature differences? And for that, having an expert on hydrology or having an expert on astronomy can also be helpful. So interdisciplinarity is an important trend in modern science. And you will notice more and more often that many papers are now written in groups. So very, very few papers are now single author. More and more papers are written in collaboration. So an advice that I like to give to my students is that in the future, they are going to be working as a team. Even if they are researchers, research today is much more collaboratory. It's much more interdisciplinary. So learning how to communicate with other researchers, learning how to collaborate with researchers outside economics, researchers from computer science, researchers from statistics, researchers from geography, researchers from astronomy. That is an important skill that I think all of us need to practice, because we think that the world is more complicated, and economics is important, but economics combined with geography, economics combined with computer science can give you very, very interesting insights that alone you might not be able to get.
Okay, thank you very much, Mr. Carlos Mendez, for the wonderful answer.
Okay, maybe there's one last question from Pak Atoila. Is there any special technical requirements for undergraduate students that want to learn more about spatial data? Maybe especially for our undergraduate student, where can we start our research about satellite data usage in Indonesia?
Okay, so there are different components. So satellite data is a specific topic, but before going to that specific topic, let me talk a little bit about the general field of the spatial data science. So if we go to the link that I share with you, if you want to start with spatial data science, here you have a collection of introductory videos. So let me see if I can open this link so I can give you a walkthrough of this tutorial. Okay, so the first thing that we need to learn is what is data science. And here you have a lecture by one of the founders of spatial analysis, Professor Luke Anseling from the University of Chicago. And what I really like is that Professor Anseling has recorded all of his undergraduate lectures of his class, and it's available in his YouTube channel. So if you click on this link that says Geoda Software, you click on this link, you will go to his YouTube channel, which is here. And as you know, there are many components of a YouTube channel. And if you go to playlists, here are most of his lectures. And if you have to start somewhere, there is this introduction to, this one. Introduction to Spatial Data Science 2021. These are the latest version of his lectures. So if you want to know how a class in spatial data science looks like, here you have 14 lectures that you can start learning. You click here. Week number 1, what is spatial data science in 20 minutes? Because these are short videos. So these are not long, boring lectures. These are short videos that focus on the most important concepts. The first week, you need to learn what is spatial data science. You need to learn what spatial data analysis is. Second week, you need to learn what mapping is all about. How can we create statistical maps? Week number 3, we learn univariate and multivariate analysis. Week number 4, we learn spatial autocorrelation. Week number 5, we learn about global spatial autocorrelation. And then we continue. So this is a very well organized course. It's short and it's very high quality. So definitely, if you want to start, and if you are an undergraduate, this is an undergraduate class that I highly recommend. Of course, it's in English. It's a very well spoken English, high quality. The sound is great. Highly recommended. That's why that's the first video that I put in my tutorial. But then the other videos are going to give you more information on what is spatial data science from the perspective of other researchers. And then it's not only enough to understand what data science is. we have to start using data science. And one of the recommended programming languages for doing spatial data science is Python. And here you start using Python. You start learning what are the commands to use Python and what are the libraries for spatial data science. So Python has a library called Spatial Analysis Library, PySal, the Python Spatial Analysis Library, that is going to teach you how to visualize maps, how to model spatial phenomena, how to explore data. And here you have a 3-hour, okay, so this is a 3-hour tutorial on how to use Python for spatial data science. So you have all of the materials here to learn how to use Python for data science, how to use Python for spatial data science. You have the materials on introduction to data science and spatial data science. So you have more than enough in this tutorial. So when I give this to my students, it usually, sometimes depending on how much time they have, very highly motivated students can finish this in 1 week. The average student can take all of these materials in 1 month or 2 months. But the materials are there. The only thing that we need is highly motivated people. The field of spatial data science is so welcoming because we use open technologies. We are open to anybody who wants to learn. Is more than welcome to join us because the materials are there. Python is open source. Python is free. If you have a Gmail account, then you can run Python in the cloud for free. All of these courses are free. The only thing that we need is highly motivated people who want to join us. So if you are motivated and if you have time to learn, you have enough to learn from this tutorial. But of course, along the way, you will also find other resources. But the place to begin, at least the way I started learning, is from Luke Anseling and his software. So he has a software which is not Python. He has a software called Geoda, which is very friendly, but you can also explore Geoda. So I started with his lectures, with the books that he recommends, and over time I built my own style. So I didn't took a class. I learned by myself. And of course, that is costly and that is time consuming. But now my job is to help my students in this journey. So now we have a class on regional development in GSID where I teach all of these things with more time. And essentially now, at least my students, they have a clear roadmap that I didn't have when I started learning this. But now all of you, if you are really motivated, you can explore all the sections of these tutorials. And you can go from learning how to create basic maps to learning how to model the evolution of the spatial inequality. So you can go from very basic stuff to more complicated stuff, okay?
Right.
So there is one more question in the chat that says, Mr. Mendez, can you share the link again right now? So yeah, so I'm gonna share 2 links. The link to this specific tutorial, it's in the chat for all of you. That's the link to this website. But if you are really highly motivated, you can go to my tutorials website, which is also open source. You click here on my name. And this is the place where I like to store my open source materials. Because as a professor, I like to share whatever can be shared with the world. And if it's a material that I create, I'm more than happy to share it with anybody, in particular, because coming from a developing country myself, I know that coming to Japan and study with me, it's expensive. But I would like to share these materials with students who do not have the option to come and study with me. They just go to this website, which I'm also sharing in the chat. And in this website, you will find many of my tutorials that I use in my courses, like how to create interactive graphs, how to access World Bank data, how to create maps in different ways, how to do spatial analysis, how to do many, many things. So this is essentially one of the ways in which I look forward to contribute to developing countries. And that is making my learning materials available when they can be shared. Of course, I cannot share everything, but if it's possible, I try to share as much as I can. And so if you're highly motivated, you can also find many interesting tutorials. So here I have a tutorial on the Human Development Index across the states of India. So, and the data is included here, the code is included here. Essentially, we only need motivated people. The materials are there, but the motivation is what you need to bring forward. Okay.
All right, thank you, Professor Mendez. Unfortunately, we have limited time for today's session, so I think we are at the end of today's lectures. And there's so many points of view that we as a social science student might rarely have seen before. On behalf of the Department of Economics, again, we say thank you for today's lecture. And for all participants, we hope that today's lectures may bring you new points of view and many motivation to go extra mile with your research. Please don't forget to fill out the attendance forms, which I have right in the chat box. And we also have another lectures on Friday with Professor Christian Ochia, also from Nagoya University, at 13 Jakarta Times. So we hope to see you again in the next lecture. Good morning and wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much. And
thank you very much, Professor Mendez. We hope to see you again soon.
Yes, thank you very much. And let's keep in touch.